Hello everyone, I am Zacharias Sawadogo, PhD student in Gaston Berger University under the Passet Scholarship. I am pleased to present our work about Android malware classification, updating feature through incremental learning approach. The outline of the presentation will be as follows. We state with the context and the problem, then some related works and our contribution. After that, we present our UFILA approach followed by experimental process. Next, we present the result and lastly we conclude. The growth in cybercrime has triggered a lot of research to detect or classify Android malware. According to Zoe, many developers of malicious applications use obfuscation techniques such as dead code insertion, decryption, transposition to hide malware, or create variants to escape detection. This makes models obsolete because they cannot detect vulnerabilities that are not taken into account in the training of the model, according to Schiller and al. Lilly Lee and al. Have developed an incremental learning method to add new class to the existing classification model. Lopez and al. Propose a new incremental learning approach to solve the problem of identifying people of interest from training face data. Shangani and al. developed, developed an incremental cross-mail spam feature. The proposed approaches either solve a lack of data or a problem of large amount of data that cannot be provided to the model at once. This this is a horizontal update, which means an update of the data. The literature explored did not address vertical update that involve features, but the UFILA approach, our approach, makes a vertical update. Our contribution can be reasoned by 2 points. The proposal of UFILA, which is an efficient and functional system for classifying and identifying Android malware, enabling the future updating. The evaluation of the efficiency of UFILA using of classification algorithm. In the figure 1, the features, the data set, the data set make up of four families of features is divided to four batch noted D1, D2 to D4. Feature update and backup. The update and save function allow first to recovery one by one the copy of the DI by concatenating them progressively. The updating of the feature and the saving of the copy of the concatenation are carried out. The data pre-processing. Data pre-processing states clean up the data, scan it, and subdivide in two groups, the training set and the test set. The training and model. This this step this step allow to train algorithm in order to obtain a classification model. A testing and prediction result. In this step, we test the performance of the obtained model with other data different from used for training. For the implementation, we use a data consisting of 214 features vector extract for 15,036 application malware and Benin. For the needs of our experiment, we have to separate the feature by categories and we obtain 4 datasets. For the implementation of our approach, we select through the literature 30 classification algorithm that we test and select the best for our model. We use the standard confusion matrix metric to evaluate the performance of our approach. We observe in the figure 2 for for algorithm that our model became more and more precise when going from di to di plus 1. This the accuracy of the model has increased considerably from the initial dataset to the final dataset. In addition to the increase in accuracy, the model experienced an improvement of the accuracy as we had features. The figure 3 show the precision will recall and F1 score matrix obtained by the UFILA approach applied to the dataset. For the matrix vary for both classes between 96% and 100% for each of the two used algorithm, random forest and decision tree. The figure 4 show the precision recall and F1 score matrix obtained by UFILA approach applied to dataset 4. The matrix vary for both classes between 98% and 100% for each of the two used algorithm, extra tree and light gradient boosting. This allows us to say that the model bring from UFILA approach achieve very good performance value in terms of classification while updating the feature. With the UFILA approach, classification algorithm outperform the result obtained in classical machine learning. In this paper, we propose an incremental learning approach UFILA for Android malware detection and classification. We use classifier and a feature updating function. We evaluate UFILA using four separate features data from the same malware and benign data. Our proposed approach outperforms many automatic malware detection approaches in the literature. In our future work, we plan to improve and optimize with update function. We thanks Parset Exif for her financial support of our work. We present an excerpt from our literature reviews. Thank you for your attention.